clap. We are going to break down a smart and tricky problem that is called maximum difference between even and odd frequency 2 from the Leetcode. And we will not only solve it, but we'll also understand how to do it efficiently using the bit masking and sliding window approach, right? And there will be some cool tricks also that contains the frequency states, and then we will understand, right? So what we have given, let's read from the questions, right? So you are given a string s and integer k. Your task is to find the maximum difference between the frequency of two characters, frequency at a minus frequency of b. So in a substring subs of s, means there is a substring subs of s such that subs has a size of at least k, and character a has odd frequency and character b has even frequency in subs, means substring. Then we have to return the maximum difference, right? It is also saying that note it contains two distinct character in the sub, right? Means what we have given a string s, right, as you can see here in the example, and this s contains the digits from 0 to 4 and integer k, right, as you can see. Then we need to find the maximum difference. What is the maximum difference? You can find the frequency of a minus frequency of b in the substring, right? So a and b are different characters in the string, right? Two characters we have in the string, in the substring, and so the frequency of a will contains the odd and frequency of b will contains the even, and so the substring is at least k size should be there, right? So k size of character should be there. It should have at least two character in here, means the string length is at least k and has at least two b characters, right? So let's dive into this problem and understand the logic step by step. So first of all, the example we have given is 1 2 2 3 3 and k is 4, right? The string contains these digits, and if you see the frequency of this substring, the frequency of 1 is 1 because the 1 is coming only one times, and the frequency of 3 is 2 times, right, as you can see here, right? And so the difference is 1 minus 2, and so it is coming minus question 1. In your mind, right, there should be a question should come from this example, that if a string s contains 1 2 to 3 and k is 4, right, why you are taking 1 and 2 pairs, why not others pairs, right? So first of all, we should understand we are to find the maximum difference, right? Means frequency of a minus frequency of b that we have given in the problem statements, means two characters we have to take, and then of the substring, and character a should have the odd frequency and b should have the even frequency, right? So a and b are distinct or different, you can say, character from 0 to 4, right? And the frequency a is odd and frequency b is even, right, as you can see here. The substring has at least k size, right? Means it should be greater than equal to 4, maximum greater than equal to 4, and the substring contains at least two occurrence of b, right? Means the b should have at least come 2 times. So if we will take a that is coming 1 time, the b can be either 2 or 3. That is a question you should come, right? So you have to think that we have to try all the pairs a and b from 0 to 4, right? So we need to check if there is any substring, right, any valid substring that length is greater than equal to 4, right, that satisfies the condition, right? So what are the pairs will be there? So first pair will be a is 1 and b is 2, right? We can take, but in this example it is saying b is considering directly is 3, now taking the 2. So we check every substring length is greater than equal to 4, right? And what is the substring here is now substring will be 1 1 2 and last is 3, means the 0 to 3 index, the substring that contains, right, we have to check the every substring of length greater than equal to 4, and so the first substring, let's suppose, is what, 1 2 to 3, right? And index is from what, 0 1 2 and 3, right? 3 indexes are there. So the frequency at 1 is what, 1, that is odd, that is fine. But frequency of 2 is how many, is even, that is 2, right? And we'll not consider now for 3 because we are only considering 1 and 2, right? What is the length is here? Because the length we have taken from here to here is 4, right? From here to here, right, is 4. Length is 4. So there is 2 more b's, right? That is valid, right? 1 minus 2 if we'll do, right, it will come what? 2. So because 2 having the more than, because 2 have a 2 or more b's, right, that is valid, right? And so the difference is frequency of a, if we'll take a is 1 and frequency of 2 is 2, and say it will also come minus 1, right? And if we'll take over all of these, right, means if we'll continue to check substring 1 2 2 3 3, means the index from 0 to 4, right, means the frequency of 1 is 1, frequency of 2 is 2, frequency of 3 is 2, means extra character doesn't matter, right? But it's coming sorry. So what I'm saying, the pair can be 1 or 2 or 1 or 3, because if we'll take the frequency 3 3 right here, means this is also frequency coming 2, means there is an extra character that doesn't matter here. Understood, right? So that is why the answer is coming 1 minus 2 is also coming minus 1. So it doesn't matter that example is saying you that frequency of 1 and 3 not is considering the 2, right? But you have to understand, we will go through all the pairs, and then you have to assume the pair is what? Pair is either a is 1 or b is 2, or a is 1 b is 3, like that you have to understand. Okay, so you also check, you can also check your, or you may also check other pairs, like if we will take a is 3, right, and b is 2, right, or etc, we can take any other things we can take, right? Combinations can be anything, but none of them given a higher value valid difference more than minus 1. If you assume, if you go through all of this, you will understand. I have gone through, that is why I'm saying. Okay, so first of all, the final result among all of these will become what? The valid a and b combinations, and all the substring having the length greater than equal to 4, that having greater than equal to 2 b's, you can say. So the maximum difference, if you calculate, it will come minus 1, right? And so you will also ask us, right, why not 0 or higher, right? Why not 0 or higher? Means because any other valid substring either doesn't satisfy or does not satisfy the parity conditions, or even a or b, right, they don't contains b's, right? So the resulting difference is lower than minus 1, right? If it is not, we will not return 0, we'll return minus 1 itself, right? So the final answer should be minus 1. Okay, means any other substring either doesn't satisfy the condition for a or b, right? Either a is not having the odd frequency, or b doesn't have the even one, right? If any of these condition doesn't satisfy, so the parity condition will fail, means odd a and even b, right? And so they don't contains the enough b's, or the resulting difference will be lower than minus 1, and so we'll return minus 1 in this case. So there is not given that you have to return that, right? The maximum difference you have to return if this not contains, if it is not contains any of these conditions, right? It is doesn't satisfy this condition, it means you have to return minus 1 as a max difference. Understood, right? So okay, so first of all, if I'll talk about the steps, what are the steps we should understand, right? So these are the steps that we will go through, right? Means we will loop all the valid a and b pairs, right? Then we'll use the sliding window to track the substring, means left plus 1 will do, and the right will stay there, right? Means we will slide the window from left to right side. Then we'll track count of a and b, and their odd and even parity will find, right? And then we'll maintain the lookup of minimum prefix difference for each parity states, and then we'll flip a parity check for valid condition using the JOR, right? And finally we'll update the answer if a valid prefix state has been seen before, right? So these are the steps we'll follow, right? And this is our intuition that we will understand through the problem, right? Because the problem statement is saying that we have given string, right? Let's see here. We have given string, and the digits in this string is from 0 to 4, right? And integer k we have also given, right? So we need to find the max difference, right, between the two character frequency. Let's say frequency a and b will do the difference. The a should be odd and even should be b should be even, right, the frequency. And so the string substring length should be less than at least k, or there should be at least 2b characters should be there, right? Means these are the steps that we are going to follow. So first of all, we'll find the length of the input string, then we'll write answer, or you can say max difference result value here as a integer dot mean value. Then we'll go through all the combination. We'll try all the combination of two different digits from 0 to 4, right? Between 0 to 4, all the combination we will try, right? See, why? Because we are doing, if we'll go for the brute force approach, right, you will try this approach, right? At least you will write this so this is the brute force to find all the pairs, right? So we will try all the combination of digit from 0 to 4 as character a and b we have, right? But we skip if they are same. Why? Because a and b must be different, right? So if a and b are same, right, in this case we will skip. Means we skip if they are same, because if they both are same means there will difference will always come 0, right? That is why we will say the we will say it should be a and b should be different, right? You understand, right? Then what we need to do, we will in the next step we will initialize the tracking variables, right? So we'll create the best, you can say, array, and it will store the minimum values for each parity state, right? So we are going to use here a sliding window from left to right side, okay? And so we'll take a count a and count b, and there will be also, so this count a and count b will be our the total count from the start to the right? And there will be a previous a and previous b. So these two variables will track the count in the excluded prefix window, right? Excluded prefix window will take what is the previous a and previous b, right? And so we'll track the count in the excluded prefix window. Then there then we'll at best at state, right, will store the minimum difference seen so far for the state, right? And so that we will do the sliding window, right? So as you can see, the next step what we need to do, we have to slide the window rightward. So as we slide the right pointer, right means right plus plus will do, right? If we will slide the right pointer, we'll keep updating how many a is there and b is there. I mean, how many a is there, how many b's characters are there, we have seen, right? And for that we'll count the character as a and b if it matches. Let's suppose if character a is coming, we'll increase the count a. If character b is coming, increase the count b, right? We'll keep doing that, right? And in the next step, right, what we are going to do, we will shrink the left if needed. So let's suppose we'll do right minus left if it is greater than or equal to k, right? And count b minus count b previous if it is greater than or equal to 2, right? In that case, we'll shrink the window from left while the condition will hold. Until the condition will hold, we'll shrink the window. Means we only care about the window of length k greater than or equal to k. We only care we only care about the windows of length greater than or equal to k with at least 2 b's character, right? So if our window is too large or meets the condition, we will try moving left forward to find the smallest valid prefix, right? And so we'll compute the current prefix parity states, and you have the get status method. that will give you the left status, right? And at the you have to at the best at left status, how we are going to find the previous A minus previous B and the best at left at a status. So you will update the best value for the parity state like this, right? Means what we are doing here, we record the best prefix we have seen so far for the current odd or even parity of A and B, right? Understood, right? Like this. And then we will slide the you can say we will slide the left pointer forward and update the prefix, right? So do plus plus left and just increase the previous A and previous B. Okay, in the next step what we need to do now, now the time comes for the magic, right? Means you have to find the get status, count A and count B, right? And we only want to compare with the prefix that has or had the different A parity but the same B parity, right? So you have the count A and count B, understand? Then we will make the JOR of this A's parity and B's parity the same, right? We will keep the B parity same, right? And for that we'll write status, we'll make the parity and we'll get the flip status. So what we are doing here actually, we want we only want to compare with the prefixes that had a different A parity but we will keep the same B parity. We do this by flipping the second bit JOR, using the JOR, right? How the right status and will pass the 0B110, right? So why? Because the total A frequency will now be odd when the prefix was even or vice versa, right? For that we have to flip the status. Understood, right? Okay, then what we need to do, we have to update our answer, right? And to update the answer, you first find the current difference and you update the answer. Means we will update the answer by clicking the by checking the you can say the current difference minus the best flip difference, right? And then in the last we'll check the parity state encoder and through the get status here, right? This is the last step that we will do. Means this is a helper method. The helper method will encode the parity of A and B into 2-bit integers. How? So with the bit 1 parity of A 0 is even, 1 is odd. For bit 0 parity of B, 0 is even, 1 is odd, right? Like that. Means this function will give you a unique number from 0 to 3 for all the possible odd and even combinations of A and B, right? So it uses a Bitmasking, a very smart trick, right? And finally after that you will return the answer, right? So after trying all the pairs, we will return the maximum valid difference that we have found, right? And we'll return the answer. Okay, so let's recap what we have used here, right? So we have make a double loop, right, of A and B pair. We have used the sliding window to manage the substring of length greater than or equal to k, and then we have bitmask the encoding parity states, and we are tracking the best preference difference to compare, and then finally we'll do the JOR operations for to check the valid transitions, right? And that's how we solve a tricky Leetcode problem, and it's a very good approach to break down this type of problem in a very simple way, right? And I tried my best way. If you have any doubt in this video, please ping me in the comment box. If you found this video helpful, don't forget to like, comment and subscribe. Let me know if you like this video, right? And thank you for watching this video, guys. Thank you, guys. Thank you for watching this video. If you found this video helpful, Please like, subscribe, and let us know what you want to learn next in the comment below. And thank you for watching this video.